Hey guys, so I wanted to go over our lesson from today or from Thursday, depending on what day it was that you were here and what day it is that you're watching this. But this is about inverse trig functions. And so doing those trig functions, but kind of sort of backwards, okay? So there's a couple of things that I wanted to share with you and I wanted to show you. First of all, I printed out my favorite thing ever, the unit circle. And so if you remember, okay, the trig functions are sine, cosine, tangent. And if you can also remember, sine is y, right? Cosine is x. Tangent is y over x, okay? So if I said to you, hey, what is the sine of 30 degrees or the sine of pi over 6? You're going to go to that angle and look at the y value, okay? So the sine of 30 degrees is 1/2. This time, though, I'm going to go backwards. And so I'm going to say to you, hey, when is the sine 1/2, right? When is the sine 1/2? And so your answer will be the 30 degrees. Or pi over 6. Remember, those are the same thing. They're just dressed a little differently. Okay, they're wearing a different outfit, so to speak. Just different names for the same thing. Okay, so that is what we're doing. So this is the trig function. This is the inverse trig function. Okay, so that's what the topic is that we did on Thursday and Friday. Okay. There's a couple of things, though, about the unit circle that we need to look at. And so let's use that idea or that example of the sine of 30 degrees being 1/2, okay? So that's this value right here. Now, there's another place on the unit circle where the y value is 1/2. And as I look at all of my y values, I find it, okay? It's over here. So, and none of the other ones, by the way, are a positive 1/2, okay? So 30 degrees is one potential answer, and then 150 degrees is another potential answer. They're actually both correct. Now keep in mind, we also talked about coterminal angles. So remember, if this is 30 degrees, this is also 30 degrees plus 360. So if I go all the way around the circle, right? 30 degrees and 390 degrees, those are the same angles. That's the same terminal side, the same destination, so to speak, on the unit circle. If likewise with 150, if you add 360, you're going to get 510 degrees, and so that's the same ending point as the 150. You can also subtract 360, and so go clockwise around this angle, and so 30 degrees is also the same thing as negative 330 degrees, right? These are the same thing, negative 330, okay? And so that sort of thing. So just kind of keep that in mind, right? There's 1.5 million different answers for these. And so what we have to do is we have to say, okay, look, we got to make this smaller. We got to make this a little bit easier to understand and to identify which one of those answers do we want, right? We could be here all day. We could add 360 all day long and have 1.5 million different answers, like I said, where the sine is 1/2. And so we have to limit the choices that we give, okay? So we're actually going to use those restrictions, those limitations, and we're going to do what is called define the boundaries. This is not defined as in a definition, it's just defining the boundaries. And so again, we're placing restrictions on where these angles are, which one of these angles we're actually going to talk about, okay? So that's the first thing that I'm going to put on here for you and write down for you. So, and I promise I will show you via the picture, the unit circle, in a second. But the inverse sine, when you put in the y value, okay, because remember sine is y, so when you put the y value here, the angle that you're going to get out, the boundary where we want to keep it, we actually want to keep this angle between negative pi over 2 and positive pi over 2. Now, I'm going to start using and writing things in radian mode. I know that for a lot of you, especially with the unit circle being new, degrees are easier for you to understand, but from here on out, like pre-calc, calc, right, almost 99% of the time you talk about things in terms of radians. And so I'll give you some degree stuff, but I'm going to use a lot of radians instead, okay? But here's what I mean by the negative pi over 2 and positive pi over 2. If you take a look at the unit circle, right, the unit circle, remember, is on the coordinate plane, and there are 4 quadrants, right? This quadrant up here is quadrant number 1. In quadrant number 1, your x is positive and your y is positive, okay? And so that's something to kind of think about, right? Over here in quadrant number 2, okay, our x is negative, right? Because remember, this is the origin on a coordinate plane, right? So our x is negative and our y is still positive. And so when we're doing the sign, especially the inverse sign, we don't need to look at both of these angles because they're both going to be a positive 1/2. And again, we just don't need to look at them or talk about them or worry about them. This 30 degrees that's right here is the same as this 30 degrees. Do you remember when we drew those triangles? So if I were to drop this perpendicular, right? This triangle right here, this angle is still a 30 degrees. That's the same triangle that would get built over here. And so we don't need to necessarily look at both of them. So this angle is fine, okay? Remember, pi over 2 is 90 degrees, right? So this angle is perfectly fine. Down here in quadrant number 3, this is where your x and y are both negative. And so right? Oh, our y changed, right? Now it's negative, okay? But over here in quadrant number 4, our y is also negative over here. Your x is positive, but your y is negative. And so what happens is if you end up with a positive y value, you're going to look at quadrant number 1. If you're in a negative y value, just look at quadrant number 4. That way, you only have to focus on this half of the circle, okay? You only have to focus on that half of the circle. Again, the 1/2, right, this 30 degrees is going to be the same over there in quadrant number 2, so we don't have to give that answer. So that's why this is defined from negative pi over 2. Remember, angles that are negative go clockwise, not counterclockwise, they go clockwise. Okay, so negative pi over 2 to positive pi over 2. So whatever sign value you have, and you can see the numbers change as we go, right? They change as we go around the circle, okay? They do. Sometimes they're positive, sometimes they're negative, but these are the angles that you're going to give as a response, okay? And again, I promise we'll do a couple of examples in just a second. Let's talk about cosine, though. So the inverse cosine, remember the cosine is the x number, right? So when you do the x value and you look at the x value and you want to look at what the angle is, the 2 quadrants that are easiest to look at is quadrant number 1, where everything is positive. And remember, this time we're focusing on the x, right? So in quadrant number 2, it changes to a negative, and so that's the quadrant, the 2 quadrants, that we're going to focus on. Okay, so x is positive over here, and then it's negative over there. So the cosine is going to be defined from 0 to 180 degrees, or from 0 to pi. Okay? So from 0 to pi, that's when it's defined. Okay? If we look at tangent, so the inverse tan, right? Remember, tangent is sine over cosine, or y over x. And with tangent, positive divided by a positive is still positive. If you jump down here, a negative divided by a positive is a negative. So the tangent is positive in quadrants 1 and 3, and negative over here. because the y is in the numerator, we usually talk about the tangent being defined from negative pi over 2 to positive pi over 2. So this one is the same as the sine. Okay, now what does that mean, when we're actually doing these problems? That's what we're about to do. Okay, so let's go do a couple of examples so that you kind of see what I'm talking about, all right? All right, so these are the examples that I want to do next, okay? So again, we're looking for the angle when the sine is negative root 3 over 2. You're looking for the angle when the cosine is root 2 over 2. And then we're looking for the angle when the tangent is root 3. And again, I'll show you where that fits in those boundaries, okay? So if you envision or visualize the unit circle, it does make things go a little bit faster. But we're looking for the inverse sine to be at negative root 3 over 2. So I want my y value at negative root 3 over 2, and I see it down here, and I see it down here. Okay, so I see it in quadrant 3, and I see it in quadrant 4. Okay, well, sine is both of these answers are correct. Okay, both of them are correct. 4 pi over 3 and 5 pi over 3, totally correct. But we don't need to be redundant. We don't need to write them both down. We can, just define it. Dude, it's going to be the same as this one, okay? So this answer is, in fact, 5 pi over 3. However, we don't want it in terms of 5 pi over 3, because 5 pi over 3 is bigger. It's outside of this boundary that is the same, remember, as the tangent. It's outside of that boundary. And so we really want to call it, we want to give it a different name, okay? So if we were to go clockwise, starting at 0, down from 360 to 30, this is the same as negative 60 degrees, which is the same thing as negative pi over 3. Okay, and so it is preferred to give this answer over the 5 pi over 3. Okay. All right, let's go do another one, right? Let's do the next one. So when is the cosine, what angle is the cosine? A positive root 2 over 2. And so if we look back at our unit circle, cosine is x. Here it is positive. Here it is down here positive as well. So both of those answers are correct, okay? Pi over 4 and 7 pi over 4 are totally correct. But if you remember, cosine is defined in 1 and 2. And so the answer that we give is this one. So we're going to give the answer as pi over 4. And here's kind of the cool thing. So mathematicians, right, math people know, look, if you have a negative pi over 3, they already know that's the same thing as 5 pi over 3. Okay? They already know that. Does that make sense? They already know that, okay, because, they're smart people. All right, tangent. When is the tangent? I'm also going to show you something else, too, to kind of help solidify that. But when is the tangent equal to root 3? So the tangent, remember, was y over x. And so the tangent is going to be root 3 when your y value is root 3 over 2, and you're dividing it by 1/2, and this is your x value. Because remember, when you do fractions, you keep, change, flip, and so this is the same thing as root 3 over 2 times 2 over 1. Okay, so we are looking for this point. We're looking for the point where the x is 1/2, the y is root 3 over 2. When does that happen? And so that is going to happen way up here, okay, at pi over 3. And since I'm already in quadrant number 1, we use that angle pi over 3. Okay? All right, so these calculators, this is the other reason why we have to give it a definition. We have to define that boundary so that we can type in a program for a calculator. Program the computer to give you the right answer. Remember, the sign of negative root 3 over 2 was negative pi over 3. That's why this answer is negative. This is reason number 52, why it is massively important that you know your unit circle, because what in the world does negative 1.047 mean, right? What angle is that?